Edge AI. Here you go. Same structured format for Edge AI. Edge AI in artificial intelligence. Intermediate means advanced, AI at the edge. Introduction. Traditional AI systems often rely on cloud computing, where data is sent to servers, processed remotely, results returned. However, this approach can introduce latency, privacy concerns, dependency on internet connectivity. To solve this, AI is moving closer to where data is generated, the edge. This approach is called Edge AI. What is Edge AI? Edge AI refers to running AI models directly on local devices. Edge devices, instead of relying on centralized cloud servers. In simple terms, Edge AI equals AI running on devices near the data source. Example concept: device, camera, phone. Means local AI processing means instant decision. Why Edge AI is important? Edge AI is important because it reduces latency, improves privacy, enables real-time decisions, reduces cloud dependency. Without Edge AI, device means cloud means delay means slower response. Key components of Edge AI. 1. Edge devices, smartphones, IoT devices, embedded systems. 2. AI models, optimized models for devices. 3. Hardware acceleration, GPUs, NPUs, TPUs. 4. Data processing, local inference. 5. Connectivity, optional cloud integration. Edge AI architecture. Key layers. 1. Data source, sensors, cameras. 2. Edge device, local processing. 3. AI model, inference on device. 4. Optional cloud layer, storage or training. 5. Output layer, real-time action. How Edge AI works. Workflow: collect data from device. Down pointing arrow, process locally using AI model. Down pointing arrow, make real-time decision. Down pointing arrow, optional. Send data to cloud. Example: conceptual. Def edge _I. Data. Return processed locally on device. Print. Edge _I. Camera input. Key technologies used. 1. Model optimization, quantization, pruning. 2. Lightweight models, efficient architectures. 3. Hardware acceleration, edge GPUs, NPUs. 4. Frameworks, TensorFlow Lite, Onyx Runtime. 5. Embedded systems, low-power devices, real-world applications, smart cameras, object detection, autonomous vehicles, real-time decisions, smartphones, face recognition, IoT devices, smart homes, healthcare devices, wearable monitoring. Advantages of Edge AI. Advantages include low latency, enhanced privacy, offline capability, reduced bandwidth usage, real-time processing. Example concept: Edge AI means faster plus private plus real-time. Challenges of Edge AI. Challenges include limited compute power, model size constraints, hardware dependency, deployment complexity, energy efficiency. Edge AI versus Cloud AI. Cloud AI, centralized processing. Edge AI, local processing. Comparison: cloud means powerful but slower. Edge means fast but limited. Best practices: optimize models, reduce size and latency, use efficient hardware, improve performance, balance edge plus cloud, hybrid approach, monitor devices, ensure reliability, focus on security, protect data. Future of Edge AI. Future trends include AI-powered IoT expansion, smarter edge devices, real-time autonomous systems, 5G-enabled edge computing, distributed AI systems. Example concept: future means AI everywhere at the edge. Concepts learned from Edge AI. Understanding Edge AI helps learners understand. Checkmark how AI runs on devices. Checkmark how real-time AI works. Checkmark how to optimize models. Checkmark how AI integrates with hardware. Checkmark how distributed AI systems operate. Simple definition. Edge AI. Running AI models directly on local devices for real-time processing. Final summary. Edge AI brings intelligence closer to where data is generated. It enables real-time decisions, privacy-focused AI, efficient systems. It is essential for building IoT systems, autonomous devices, smart applications,